So we got the machine here. LTC 30. The control. Okay. There's a part running there. First thing you do to the machine, obviously you plug it in at 220.
It depends on what the customer asked to deliver. So it can be also 220 or 380.
So James, in terms of our current controller, it is Mach 4 based with the 32-bit foundation, with the interface running on top for Tensile. We do have future expansion plans to bring in a FNUC controller. In fact, in the very near future, it'll be FNUC based with the overlay. So right now we're still sticking in, and all of our customers have the Mach 4 base, which allows us to remote access the computer if we need to do updates and that kind of thing, and control it from headquarters. But in the future, it'll be FNUC based, actually, probably January of 2024 kind of thing.
So there's a breaker here on the side of the machine. It's actually on the left side. Okay. Once we plug the machine in, we connect the air. Let's see if I can show you the air. There's the air. The air is used to pressurize the spindle and also for the tail stock. The minimum requirement is usually 90 psi, but we have found that 90 psi is a little bit too much for the tail stock. So you might want to, when you get there and you turn on the machine, you might want to reduce that to 50. Can you see the numbers there? It says 51 at the moment. So once you connect the air, you can lift that gray knob. You can lift it here. It lifts up and then turn it. And you can change.
In fact, you can regulate the pressure with that knob.
Yes. The thing is, if you go too low, below 80, it will go red.
Okay.
You see, it goes red and we have an alarm. So I reduced the threshold for the alarm. Now I reduced it to another number. I'm going to show you how to do that. You press the center button. I don't know if you want to write this down. Press the center button. And then you can change the pressure at which you have an alarm. So it was 90. And I want you to reduce this to whatever value you need. I think 40 is a good number. So press the center button and then use the both arrows on the can you see there are 3 buttons there?
It's going to be
there's three buttons. The center one, you press it once and then you can use the arrows on the opposite buttons. Now it's set to 40. When I raise to 40, after it does 40, the alarm will go away. See, after 40, no alarm anymore. So it will just depend on the needs of the customer. Sometimes the tail stock might be too strong.
Can you change the sensor to metric?
You can. All these values here are in inches at the moment. The filter, the manometer can be worked in bars. I'm going to send you the procedure. But the control at the moment is only inches.
We have something actually in the works right now for bringing in the metrics. So we should be able to update the software remotely to bring that to them once it's on site.
A high-low pressure switch, does that generate an alarm on the control?
Yes, that's why we had to change the number at which it generates an alarm. Okay. Usually from the factory is 80 pounds per square inch, and you can lower that to 40. So there's the machine. Once you turn it on, you use the breaker on the side, as I said. Now, after about half a minute, the control will turn on and it will look like this. The first thing you have to do after the machine turns on is to rotate the knob, the red knob here, the emergency stop. You rotate it clockwise a little bit, and then it pops out. That's the first thing you do on the control head. The second thing you do is press enable on the bottom left-hand corner. It's here. I press enable, and if we have air, the machine should be on now. It's good to see. You won't be able to read it here, but there's a line at the bottom. This line is very important to you. This line will tell you any messages that the control wants to convey to you, like there is no air or the telestock is not out. Every time you see that the machine is not working for any reason, it doesn't do what you want it to do, read here, because that will give you a clue of what's happening. Okay, and now it's telling me the machine is enabled, soft limits active. So we're in a good position now to operate the machine. Again, and then we press enable on top here. Sometimes it's here on top, sometimes it's at the bottom, depending on the screen you are. This says enable. Okay, I have enabled the machine. I didn't do anything else, just enabled it.
Just a quick question. When we are setting these up and they are delivered, are there any kind of brackets bracing it for transportation?
So, Carlos, just to confirm James's question, James was asking as well, are there any preventative measures installed on the machine just to keep the components internally safe during transit?
No. Just the control probably comes tied to one side. It's all external. There's nothing inside you have to do when the machine is operated. So you just have to unbolt it from below the pallet, lift the machine, and then you have to install some legs that are provided there's some legs provided here. The machine comes with this readme, okay, and it will explain to you how you do the installation. And it comes with some legs and some separators and some legs.
Okay.
So you lift the machine, you unbolt it from underneath, then you bolt the leg that come with the machine. Okay, once you have the machine on the bench, again, do what we just did, turn it on, grab the hand wheel, select the axis you want to move, like the Z-axis, and then the speed at which it's going to move, X1 and X10. It's here. And then to move the axis, we need to press the lateral push button. Now we can move it. Can you see it moving? I recommend that you use X1 or X10, not X100. Okay. Let's see. I don't like the X100 because it moves too fast. It's really dangerous because it accumulates pulses and then you cannot stop it. So I recommend you to use X10 and X1 only. Then the X-axis, the same up and down. The second thing would be to turn the spindle on. That's what I do as soon as I get the machine. I want to test the spindle, the axis. I tested the axis already. How do you turn the spindle on? Okay, we go to the control. I just turn it on. This is the screen I get. I'm going to do home. This is home here. and then CNC in the center. And then MDI here at the bottom. You probably cannot see over there, but it's MDI. When you do that, you'll see an MDI line written at the top left-hand corner. That line says G97S500 MO3. It's always written there. No matter what you do, the controller always has that line in there. And that allows me to turn the spindle on. So having that line there, MDI, I can now press cycle start, which is the button at the top. Okay, and I'm seeing a message at the bottom. Tailstock must be engaged. Can you see? That's why I say you have to read here. But we need to engage the tailstock. Again, let's go to the screen where we engage the tailstock. It's home. Tensile. Run specimen. And then here you see extend tailstock. And as I press it, you will see the tailstock engaging. It won't allow you to turn the spindle on until you engage the tailstock. You can turn the spindle on without engaging the tailstock. If you go to Home, Tensile, Setup, and turn this parameter off. This parameter is called Enable Tailstock. We can set it to 0. You see how I set it to 0? Now you can turn the spindle on without engaging the tailstock. You can do that for certain operations like center drilling the part. I'm going to leave it at 1. And then I'm going to go back to Home, CNC, NDI. And now I can probably turn the spindle on by pressing cycle start. Spinning. This is spinning. I can use my hand wheel to make some cuts. Oh, by the way, the door has to be closed for spinning and for tool changes. Again, if you try to spin or try to do the tool change and you haven't closed the door, again, you have a message at the bottom saying, asking you to close the door. I'm going to go X-axis. Perfect. Let's continue. I press reset and the spindle will stop. Can you see the manual there?
Yep. Yeah.
You can see it. Okay.
Yeah, I see it.
1 minute. Yeah, now I see it.
Yeah, the manual is very easy to read. It's a very well written manual. It's very simple to understand, and it will tell you everything that you need to know. Coolant, the initial keys, tensile.
Mm-hmm.
This control is divided into 2. You have the tensile part, where you have the tensile pre-programmed specimens, and where you do the conversational programming for the tensile mill, and then the CNC, which is used like any original CNC machine with NC codes And that's where I turn on the spindle. I press CNC. It was easier for me to turn on the spindle from the CNC. So there's really two sides to this control. And some things you can find in Tensile, and some things you can find in CNC. If you go to Tensile, you'll find the first tab on the left is the programming of the part, the specimen. Okay, here's where you input the numbers, and we can go through all of them in a little bit. Okay, I just want to go through the operation first, and it explains everything it does. How you program the blank length and the distance from the spindle. We'll go through that in a minute. Custom programs, if the customer has a special part that he doesn't want to program in the conversational, in the Tensile conversational, he can have a preloaded CNC program parts if they're very special. I don't know if your customers have these very special parts, but you find them in the second tab. Third tab is small corrections that you do to the tools 1 to 4. When you machine and you find that the diameter is not correct, we'll make corrections here. And we'll go through that in detail in a moment. Okay, the running part screen, this is where I use the extend tailstock. You can also turn the coolant on and off. And probably run the specimen here. Setup is what we're going to do next. How to set the offset for the tools. Okay, this is the offset, and we go through that first now. This is what I wanted to get to. Okay, because this is kind of the hardest part. When you get the machine and the machine is new, it doesn't know where the tools are or where the spindle is. So we have to set the tools. We have to set the diameter, and we have to set the C position of each tool. And for that, we use, we machine diameters and we measure them. Or on the C axis, we have a, like a spacer, like a 2-inch spacer. It's explained here. This one. Okay, because all the tools are referenced from the face. For spacer, I have a tool presetter. You see this little thing? I use that as my spacer. Mine is, this is 3 inches, mine is 2 inches. So I put it here. Put a little magnet. So I'm going to touch any tool to the spacer. This is the hand wheel. Any spacer is fine. Any length, any spacer. Mine is 2 inches, and it's one with a little light. We go to the tensile mill. Stay home, tensile mill screen. Setup, which is the 4th tab. 1, 2, 3, 4. The 5th tab is setup. So we're going to set the Z axis. The Z-axis is the horizontal. Always the horizontal is the Z. The diameters are all X. So I press this window here, and I have to input the value of my spacer. In this case, it's 2 inches, so I type in 2. And you can see there's, well, I don't know if you can see, but it's 2 inches here. That's my spacer. All I have to do is touch like I did, and then set Z. Just press set Z. It's as easy as that. It would say at the bottom, tool 3 offset set at whatever. So we already set the tool offset for tool number 3. I'm going to do the Z-axis for all the tools first. It's going to be easy to explain. So I go away from the tool and then do a tool change. Tool change is here. Okay, I select tool number 1. And then change tool. When I press change tool here, the machine will go and change the tool. And then I just touch on that tool. I'm just doing what the manual says. You can read it off the manual too. It's going to be the same. Touch. And then do is set Z. And it says at the bottom, tool 1, Z offset set, and the number there. It's as easy as that. You will do that with all the tools. In this case, I have 4 tools. The threading tool is a little bit more difficult. You just align it. Align the tip with whatever space that you have there. And then again, I do sensing. Okay. Now let's do X, diameter. Take this out, very important. Go to tool 1 again. For the X axis, I want to have the part spinning. So I will go to home, CNC, like we did before, NDI, cycle starts. It's spinning now. And then I go back to home, tensile, setup. Now I have to cut a diameter. Any diameter. Now at this stage, do not move the axis on the diameter, on the X. Just move the Z, because we don't want to lose that reference. Go back here. We'll stop the spindle. Go again to home CNC to reset. And we measure the diameter. It's 0.945. And I input that number again on tensile on the diameter here. That's why I'm going to put the number that I measured. 0.943. 0.943. I put it here. And then I press X set, or set X. Now my offset on the X axis is taken. It says down here, tool number 1, offset set. Okay, next tool, number 2. I do the same, spin it. In this case, I know the diameter is there. I don't have to touch. I can just touch. Okay, I just touched. And because I know the diameter is the same, I've got it written here. I just do X set. Now the offset is done for all the tools. I've done all the tools, so I don't have to repeat them unless you want me to repeat one. Something I want to tell you about the tool installation. The machine comes with a wrench. It's a 10 millimeter wrench. It's very thin, so it can go in between the tool and the turret. We loosen these screws. Okay, we remove the tool. The tool should be installed face down, and the center of the insert should be in the center of the tool here, of the turret. So that means it goes, I don't know if you can appreciate it, it goes on the top of this groove. Okay, those are the tools. Now we need to touch up the part 0, which is going to be like that forever also. We have our part 0 is at the end of the chalk here, 0.15 inches from that face of the jaws. Tensile mill programs do not have a negative sign on the z-axis. They're all positive, so it will never touch the jaws. If you do the 0.15 from the jaw, you can guarantee that it will never touch the part will never touch the jaw. All programs are C positive. Okay, so they start at 0 here, and we machine up to the face of the part, which will be well, whatever number. Okay, we're going to take any tool and we're going to set 0.15 from the face of the jaw. Can you see the chart in the manual? Any tool. Let's say tool number 1 is the best for this. I'm going to change to tool number 1. If I rotate it, I can tell it's touching now. I'm going to move to the right a little bit until I can rotate it freely. There it is. A little bit more. Okay. Now I'm touching the jaws. Okay, I'm going to move 0.15 to the right. I can see on the screen. Okay. About 0.15, I move from the jaw. And then I go to the screen. Home. Tensile mill. Okay, and I go to this screen. And I tell it to set turn, this one. Set turn. Okay? And that will set the 0 for my parts. All parts will be in the same 0. So we don't change this ever. We just do it the first time, and all parts will reference from there. 0.15 from the face. It says here to see, turning the C offset. Center drill, same thing. Okay, now that we set all the tools, we can make a little program. For the program, it's very important to know the blank length. Can you see the blank diameters? So it's very important that we use the highest diameter that the part has, like it says in the figure. If the parts are not round, we take the highest diameter. That's where it's going to start machining. If we go home, Tensile, and then the first tab is the programming tab. At the bottom, we can see all the cutting conditions. Those are in the manual, but I'm going to go through each one of them. First one here is blank length. Blank length is the length of the blank from the chalk. In my case, 2.66. So I input 2.66. That's my blank length. This is important because this is as far as the machine is going to cut. If you put a longer value, the tools will start machining the tail stock. If you put a shorter value, it will only machine up to that shorter value. Next, blank diameter. This is what we showed you is the maximum diameter, including the edges, if it's a square part. My part is 0.94 inches. So I'm gonna write 0.94. Okay, the third one is feet per revolution. I've got 0.006. The next one here is surface speed. I've got 800. By the way, you can use those values to test the machine over there if you want. Then the next one is tool radius. Tool radius, I have 0.016. Tool radius 0.016. Tool width 0.25. That's the width of the tool, which is it's about 7 millimeters. A rough pass 0.002. Let me increase that a little bit. Each pass, it will cut that amount. Let me put 0.04. Okay, I have rough pass 0.04. Every time it passes, it will cut 0.04 inches in radius. And then finish pass is whatever I leave for the last pass. Okay, so those are the cutting conditions. Next, I want to input the program. I just give it all the parameters here for the part on my ASTM or whatever standard you have there. I'm gonna put here the length of the part, same length as I did before, 2.66. The length of the reduced diameter, let's say it's 1.5. I'm just making these numbers up. The length of this length here, let's say 0.4.
So typically these dimensions for the tensile specimens will come from the ASTM or ISO standards. We have the database, I'm sure Carlos will show you in a second, which has some of the common sizes on the system itself, which they can pull from if it's a common size that they're looking to produce. They can also update the specimen size the way Carlos is doing now and save that to the database so they can always recall the same size. Because Carlos is working just with a sample piece that's 2.6 inches long, he's just throwing in random dimensions for a tensile specimen size that doesn't exist, but just so that we can get the most out of the part and show you how it works in setting up a custom size of a tensile sample.
Okay, my reduced diameter is 0.5 and my biggest diameter is 0.75. Once I finish, I do generate tool path here. Okay, and I can see a diagram. Oh, by the way, I strongly recommend you have a mouse. You can connect it to the top here. I have a USB port with the mouse. It's much easier, especially at this stage. It's much easier to handle the graphics. So if you want to write this down, please, because it's not in the manual. With the mouse wheel, you can scale the part, the mouse wheel. If you press both mouse buttons at the same time, you can move the part around the screen. Write that down. Both clicks. Press both at the same time, both buttons. Okay. If you click on the left button, you can isometric the part. See in isometric. And if you double click, it will go back to the original view. Double click on the left side, on the left button. So there I can see the part that I'm making. I'm gonna make it a little prettier by this. The length of the reduced section is too long, so I'm gonna go back to define specimen and change the length of the reduced section to 1 inch. Generate toolpath. There it goes a little bit better. My part is really short, the material I have. Okay, let's go back to the program. We can program here the threads and the cutoff. So if we do thread, we can choose the thread diameters, and then we can make the thread. In this case, I'm gonna not cut the thread, just cut the normal thing. And we're practically ready to cut the part. I generate toolpath again here at the bottom, generate toolpath, and there's my toolpath. I should now be able to press the button and make the part. So I'm gonna put, this is the cycle start, the arrow here. You press cycle start, but it's very important to be really careful. Like here, there's a slider. I'm gonna go right to the bottom. I don't know if you can see it, but I'm gonna take it right to the bottom so it doesn't start very fast. Because if I made a mistake taking the offsets, etc., I may crash the machine. So I want to go slowly. I'm going to cycle start. I did cycle start already. It started spinning, but because my slider is right at the bottom, it's not moving. So I'm going to slowly move the slider. Okay, it's not doing anything, and it's nice that it did this because then I can show you. In order for this to work, and this is a very important point, let me reset it. In order for this to work, you have to go home. Remember where we turn on the spindle in the CNC screen here? Remember this screen where we turn on the spindle? You have to be at the run, program run. So you press at the center here. You have to be in program run. Now we can go to Tensile, home, Tensile, generate toolpath. There's the toolpath. And then we can lower the slider and start the program. The torque goes up. I control it with the slider. In this case, now I'm using the mouse to control the slider. Much easier. You see, I'm being really careful with the diameter. You see how I stop it and I keep. Okay, more or less it looks good. And I start letting it go. As it gets to the spindle, I'm going to reduce the speed so I can control it using the slider. It should start working soon. There it goes. I can now let it go because I feel it's going to work fine.
Carlos, by let it go, are you just increasing the slider to the max?
Yes, put the slider to the max. Because I tested the tool offset, I feel it's fine. The program looks good, it's not touching the tailstock. So I feel confident and I put the slider up. Okay. Now I change tools. Again, the slider slowly. I go controlling it with the slider.
In the beginning, do you have always to control the slider by yourself?
No, the approach is automatic. I'm just controlling the speed at which it does it. So I limit the speed. I'm going to reset it. Next thing we do is measure that part. I get my micrometer. So it's 0.46. So 0.46, suppose my measurement is 0.45. I want 0.45. What I do here, because I have 0.46, I need to compensate. So I go to diameter adjustment, which is the third tab. Remember this screen? And I go to my first tool. And I put minus 0.01, which is the error I have in my part. And that way I compensate. The next part I make, it should be precisely at the value. So I'm compensating for -1. Also the taper. You see taper here? If the part is not straight, exactly straight for any reason, you can adjust for this taper. Let me show you in the manual. Diameter adjustments. Here he explains how to adjust each tool. Tool number 1 is the adjustment I just made, which is -0.01. And then taper. Number 5, taper adjustment of the reduced section of the specimen. A positive value will increase the diameter closest to the chock. That's very important. So on the reduced section, we can adjust for the taper, and the more value we put, the diameter will grow on the side of the chock.